Lines, page 4, number 5. MN is parallel to the y-axis. The coordinates of M and N are M, 24, and -5, 2. Write down the value of M. Let's see. So we have 2 points, and obviously we're not going to be able to count by ones here. Let's count by twos, see if it fits. I don't think it will. We have to count by like fives or something. Okay, so let's count by fives. So -5, 2 would be about there. And then M, 24, M, 24. So something, and then 24 would be like, it would be about here. Okay, somewhere along here. And we know that MN is parallel to the y-axis. Well, the y-axis is like, parallel to the y-axis would be like that. So if we know that one of the points is here, the other point has to be somewhere on here. And if we know that we want one of the points to be 24, the other point is there. Okay, so one of the points is -5, 2, and the other point is -5, 24. And the value of M is -5. Okay? So you notice that if a line is parallel to the y-axis, then it does have the same x-coordinate for all of its points. Okay. Here, just reminding you, the gradient of a perpendicular line is the negative reciprocal of the original line, and we've discovered that in our investigation. 3D, which of these pairs of numbers are negative reciprocals? Okay, 2 and -1/2. So if you want to take the negative reciprocal of 2, the first thing you do is you turn it over, 1/2, and then you take the negative. So yes, that's right. Okay, what about this one? Is this one okay? This one's okay too, right? Flipped over and a negative. What about this one? It's flipped over, but it's not negative, so no, that's not right. -1 and 1. This is kind of tricky. So -1, you flip it over, you get -1/1, and then you take the negative and you get 1/1, and guess what? That's right. Okay. Moving on. Which of these pairs of gradients are of perpendicular lines? They're asking the same thing in a different way, because remember, gradients of perpendicular lines are negative reciprocals. So are 2/5 and 5/2, are they negative reciprocals of each other? Well, they're reciprocals, but they're not negative. What about these two? Negative reciprocals? Yes. What about these two? Negative reciprocals? Yeah, because -3/1, -1/3, it's okay. 1 and -1, also okay. All right? Moving on. Number 3, find the gradients of lines that are perpendicular to a line with gradient. Now, you can pause anytime you think I'm going too fast. So now they want us to do the negative reciprocal. So if we start out with -3, the reciprocal would be -1/3, and then we could take the negative of that, it'd be 1/3, right? What about 2/3? 2/3, we're going to take the reciprocal, 3/2, and then we take the negative, -3/2. Okay. What about -1/4? We're going to turn it over, -1/4/1, and then we take the negative, it's going to be 4. 1 is going to be -1, -1 is going to be 1. Number 4, find the gradient of any line perpendicular to the line passing through the points -2, 6, 1, -1, 5, 10, 0, -2. Okay, so let's do this. We're going to use Lin-Reg to find the gradient, and then we'll take the negative reciprocal of that gradient. Okay, especially if you're not going to graph it, you can either use the formula at the top, or you can use Lin-Reg. So I'm going to put -2, 6, and I'm going to put 1, -1. Okay, I'm going to go stat, calc, Lin-Reg, L1, L2, frequency list blank, go down to calculate. Okay, so the slope is negative 2.333. So negative 2.333 is my original gradient. And then I'm going to take the negative reciprocal. So negative 2.333333333. Okay, and then I'm going to take the reciprocal. The reciprocal will be 1 divided by that. Negative 4.28, blah, blah, blah. Negative 4.29. And then I'm going to take the negative of that, 4.29. Okay? Okay, now I'm going to show you how to do the next one. I'm just going to use the formula. The formula is this, remember? So what you could do is you could say, okay, I'm going to have point 1 and point 2. I have an x-coordinate, a y-coordinate. I'm just going to write them down here. 5, 10, and 0, negative 2. Okay? And so I'm going to say, hey, y2, negative 2, minus y1, 10, divided by x2, 0, minus x1, 5. And that's going to be my original gradient. So negative 2 minus 10 is negative 12. 0 minus 5 is negative 5. So the answer is 12 divided by 5. And then I'm going to take the inverse, 5 twelfths, and then I'm going to take the negative of the inverse, negative 5 twelfths. Okay? Alright, so you could also do that with a calculator. Number 5, each diagram shows a line and a point A. Write down the gradient of the line. Write down the gradient of any line that is perpendicular to this line. Copy this diagram and draw a line perpendicular to the red line passing through point A. Okay, so let's see the gradient of each of these lines. Easiest way to do that is to draw a triangle and count the blocks. Since it's, see if we can find like a place where they're like whole numbers, like that. Okay. So right now for this one, I see that the rise is about 6, right? Actually negative 6 because it goes down, negative 6, and then it goes over positive 2. So the original slope or gradient is going to be negative 6 divided by 2, also known as negative 3. So the perpendicular gradient would be negative 3, 1 over negative 3, and then take the negative of that, so it would be 1/3. Okay? Then we're going to draw a line perpendicular to the red line passing through point A. So it would be about like that, right? About like that. Okay, moving on to B. Let's see, the gradient for this, that's a good, nice round point, and so is that. Okay, so we got, let's see, about 4, positive 4 on the run, and we got a positive 2 on the rise. So it's about 2 divided by 4, which is 1/2. The perpendicular gradient would be, I'm using this symbol to show perpendicular. The perpendicular gradient would be negative 2, right? And if I wanted to draw a line that's perpendicular to this line and goes through A, it would be about like that, right? All right. Finally, for this one, last one, let's see. There's a whole number there. There's a whole number there. Okay. So for this one, we got plus 3 and plus 4, right? So the slope would be 4 divided by 3. The perpendicular to that would be negative 3/4. And then a perpendicular to the red line going through point A would be like that. Okay? And that's it. We're done.